Hello, welcome to Mr. MathWell. This is Pre-Calculus 30 from the McGraw-Hill Ryerson Pre-Calculus 12 textbook, and we are talking about Unit number 1, and this is the review of the whole chapter. So I'm going to go through all the sections in Unit 1 really briefly and just talk to you about the highlights of this chapter. So in Chapter 1, you'll see over here that we are talking about function transformations. So transformation is when something is changed in relation to an original. So if we have some kind of original function, we can adjust the parameters, certain parameters, to change the position of that function or to stretch it in different directions. So you've learned this in Chapter 1 already. This is the basis for the whole course. Most of the chapters are talking about transformations, okay? So Chapter 1 is really, really important. We're talking about basic transformations of basic functions like linear functions or quadratics, but we're going to explore all kinds of different functions. But these parameters that we're going to study in Chapter 1 are going to be very important the entire course. Okay, so 1.1 talked about horizontal and vertical translations. Now, translation is a movement, right? It's like a movement, either left, right, or up, down. A couple things I want to point out to you, that this format right here, y minus k equals f of x minus h. So obviously h and k are going to be two parameters that will adjust how the function moves left or right and up and down. The h moves the function left, right, okay? Notice that the h is in with the x there. So any number that is added or subtracted to x is going to move that function along the x-axis. So think about the x-axis this way. Any number that's inside the function with x is going to shift it this way, left, right. Now, I want to point out that you can put this k over to the other side, which I do most of the time, because this is the format that's used in other chapters for other functions. And what this says right here is that the new transformed function y is going to be based on f of x, so I have it highlighted up here, f of x, with this parameter and this parameter being different. That's the left-right shift for h and the up-down shift for k. Okay, so over here, I have this here. Now if this function was situated right here, okay, so let's say that's f of x, okay? And let's say I copy that and I'm going to paste it. Now this would be the exact copy of this function, and if I were to move that straight down, that is a difference of, that's minus k. I moved it down k units, so this would be minus whatever that number is. So 1, 2, 3, let's say. This would be y equals f of x minus whatever, 0, because I didn't move it left to right, plus, minus 3, okay? Down 3. If I move this as well to the right, let's say 4 units, like this, let's say, from the original, then this equation for this function would be y equals f of x. And now because I moved it right, it's going to show a positive h, or x minus 4 if I moved it to the right 4 units. So let me write that down. We're getting ahead of ourselves here, aren't we? You maybe are losing me here. So this new one here is going to be y equals f of x. I moved this to the right 4 units. So there's going to be a minus 4 in there. And I also moved it down, how many? 3 units, I think I said. So down 3 units translates into a k value here, minus 3. All right? So that's what that is. Now, it doesn't matter what the function is. Remember, the function is just f of x right here. So that's the parameters that you had there. Okay, so that's horizontal. That's left, right. What else do I have for you here? Here's a sample question. If you're asked to identify h and k and describe what they do, let's say if you have a here, y minus 5 equals f of x, okay, you could rewrite that, and I would encourage you to rewrite that, or at least think about this like this. So the new function y is the old function, just moved up 5 units. And h here, because there's nothing inside added or subtracted to the x other than 0, h is 0 and k is positive 5, okay? All right? Let's take a look at it. Excuse me. Let's take a look at another one, something like this. So h is positive 7, okay? Because remember, the format is x minus h, so h is positive 7. And k is actually negative 3. If you were to bring that over here, that would be negative 3, and that's what k is. So this represents a 7 units moved to the right and 3 units moved down. Okay, here are the key ideas. Again, 1.1, just horizontal and vertical translations or movements. 1.2, we get into reflections and stretches. Okay, so reflections, if we have a function, let's say this blue function right here that I have, a reflection is a transformation where the graph is literally rotated around an axis. So if it's rotated this way or flipped this way, okay, that's flipped about the y-axis. And if it's flipped this way, okay, in a vertical, that's flipped around the x-axis. Okay, so let's take a look here at these three. Okay, so this original f of x right here, in the left diagram, you can see that it has been flipped about the y-axis here. So this is kind of like the mirror. You see that, the mirror there. And this point has been literally flipped around to this point. This point flipped over here, this point flipped over here, and so on. This point, this point flipped over here. So, wait, what? This one, yeah, it flipped over here. I missed one. Okay, so you see that? That's rotated. Now, what is the difference there between the original point, let's say D, and its image point, D prime? Well, the difference is the x values have changed. See, the y values are exactly the same. They're both 4 for these points. But the x value, it was positive 3 for the original. Now it's negative 3. So when we flip about the y-axis, and I'm going to bring this little chart up here now. When we reflect about the y-axis down here, it's a horizontal flip, right, sideways. And the mapping, now what happens to all of the points? Well, the x is always the same. Sorry, same x. No, it's a negative x and the same y. My apologies. It's a negative x comma y. That's the horizontal flip. Okay, the x values change. This one over here is the vertical flip, like this, right? And so this d has actually come down here to this d prime. And so what's changed there? The x values are the same, but the y values are the negative version of themselves. So here x stays the same and we have a negative y. Okay. The function looks like this. Okay, with a negative y, it's y equals negative f of x, like this. So the negative is out front of the function value there. And here we have y equals, the x is negative, so this is going to be like f of negative x. Okay. And yeah, this is where we start to introduce 2 more parameters, and that's the a and the b, if you recall. Okay, so let's talk about a and b here. Those were flips. Now let's talk about stretches. So stretches are when, in this case on the left, this is a vertical stretch, right? A vertical stretch. And this point right here has been multiplied to get to this point. And when we're talking about a stretch, we don't move it, we multiply by either a bigger number or a smaller number. And so this was 4, this y value was 4, and it has been stretched up to 8. Okay, here's 8. And 0 has been multiplied as well, but it just happens to stay 0. So 4 times 2 is 8. Look at this one, 2 times 2 is 4. So it looks like our stretch is by a factor of 2. Okay, so this is times 2. And the number that we use for a vertical stretch is this a value, and that's multiplied by y. Okay, the a value. And over here, this one's a bit of a tougher one maybe to grasp, but when it's stretched horizontally, we're talking about now a b value, and that affects the x in the function. But it kind of works opposite. So if the function gets squished up, like compressed horizontally, squished like this, that means the b value is larger than 1. And so the horizontal stretch actually happens by a factor of 1 over b. So this one here, we have an x value of 6, and now we have an x value of, well, that's not a good one. I think that's supposed to be 3, but let's say that's about 3. So 6 to 3 is, let's say, a factor of 1/2. And so if the stretch factor is by a factor of 1/2, the b value is 2. Okay, your b value is 2. Okay, and everything gets divided by 2 here. 2 to 1, 6 to 3, and so on. 0 divided by 2 is still 0. Okay. So when it's all said and done, we have all of these factors that affect the graph, and yeah, we have a combination of transformations then in 1.3. And here is A. Let me just get my highlighter here. Here's A, here's B, here's H, and here's K. And those are going to be very important for the rest of the semester here. If you can grasp this chapter 1, then you're set for the rest of the semester, honestly. Like, it comes up over and over again with all these different functions. It's a big, big part of this course. So again, remember, if A is negative, right? If A is negative, that means the Y value is flipped. That's a vertical flip about the x-axis, okay? If B is negative, well, that's the x, so it's being flipped this way. The x has changed numbers, so that's a horizontal flip, okay? So remember that. All right, awesome. And then H and K just move left to right, or K up and down, okay? I should mention this now. We've talked about this already, but this is putting this right here into the mapping notation, okay? So if you know what the function is, if you know what the equation of the new one is, you can take any point on the original function and apply A, B, H, and K. So what you do to x is you multiply x by 1 over whatever the B value is. And then with that answer, you add H, okay? And that will give you your image point that matches this new function, the new parameters on this new transformed function, okay? So 1 over bx plus h. That gives you your regular old x value from your original function. That gives you the new x value for your transformed function, okay? And then over here for the y, what happens to the y? Well, the y gets multiplied by this a value, whatever it is, and then when you multiply the y by the a, then you add k, and that's your new y value. So you have a new x and a new y. And that's just mapping notation that might come in handy for you when you're trying to find a single image point, okay? Mapping notation. All right, so 1.3, the second part of 1.3, we talked about identifying an equation. And I'm not going to do it from scratch because it takes too long. If you want to watch this video, you can watch my other video, PC 31.3. You can watch that, part 2 of 2. But just a real quick rundown here. So if, okay, let's just see. So if, let's see, f of x is the blue one here. So what has happened? Well, when you identify the parameters a, b, h, and k, I would always encourage you to start with a, then move to b, then move to h, then move to k. Do the stretches first, okay? Don't figure out what this is, because the stretch and the mangling of it that way, the flipping, it's not going to be, you don't want to start there, okay? It may not be accurate. So what I did here was I said, okay, well, how wide is this whole thing, the original? It's 8 units wide. How wide is the red transformed graph? It's 2. What's that factor? Well, it's come squished in by a factor of 1 over 4. So what's B? 4. Okay. It's 1/4 the width, so B is 4. Now I just started with B. I don't know why, but A. Okay, what about A? Well, I don't have A marked on here, but we go from 0 to a maximum of 4. You see that? 0 to 4. That's 4 units. What about this one? 2 to 10. Well, that's 8 units, right? So it looks like it's been stretched, pulled up this way by a factor of times 2. So there's your A value of 2. You've got A now, you've got B. Okay, so let's try and take, now from here, what you try and do is try and take a point that hasn't moved, if you can. That would be nice. This one hasn't moved when we stretch it this way and this way. 0, 0 hasn't moved. So let's go 0, 0 to the corresponding point. I guess I should say, first of all, this hasn't been flipped upside down, right? It's still oriented the same way, so you don't have to worry about a negative A. We don't know if it's been flipped this way, and that's where the first sort of conflict comes, that sometimes a graph like a parabola, or maybe this looks like an absolute value sort of graph almost, if that's the case, you don't know whether it's flipped, because the flipped version looks exactly the same because it's symmetrical. So you could have, this could be a -4. I think that would be correct as well, but that one you can't really tell. But it hasn't been flipped upside down, right? We know that the graph does not look like this, okay? So we know that. So this point has moved to the left 7 units and up 2 units. So guess what? H is -7 and K is +2. What does that whoa, where'd that go? What does that translate into? That things are disappearing on me. -7. That translates into an x plus 7 in here. Make sure you note that. Boy, that was weird, eh? and k, this is the plus 2, here's the k value. The a is 2, that's out front of the function here, and b is 4, that's inside here. Another important thing to note, you notice I have all these brackets here? Okay, I'll highlight them in red. You see this bracket here? Okay, you have to have the brackets here. The b has to be kind of separate from what's happening to the x in here, okay? That's very, very important. If you go back to here, you see how there's a second set of brackets? If you do this, bx, and then you multiply this b in, notice how b times h is not the same as h. So if you have something like this, okay, well, h is not 5. You'd have to actually factor this out, okay? So you'd have to factor the b out, so it's actually 5 over b. Okay, I might have just totally messed you up there, but you have to have these second set of brackets in here for this thing here to be h. Okay? Okay, hope that didn't confuse you too much, but you have to watch the video if you want to see more of that. Here's another quick example. I'll let you pause the video if you want to take a look at this, but this is this is an example, and here is the solution. So if you want to just pause the video and just take a look at what I did there, go ahead and feel free to do that right now, or you can get it all in there. Okay, pause and take a look at that one. All right, moving on here, the key ideas for 1.3, again, very, very important. A is a vertical stretch. If A is negative, then it flips vertically. B is a horizontal stretch, and by a factor of 1 over B. Don't let these absolute values fool you. All that means is that if it's negative, the negative is more a part of the flip, and the flip than it is the stretch. The negative isn't really part of the stretch. Okay, if something is 2 times as big, it's negative 2 times as big doesn't really make sense, right? The negative is the flip. And the actual number, that's why they put absolute values there, the actual number is how much it's stretched or compressed. H, horizontal translation, K, vertical. Okay, one more section I believe here is the last one here in our chapter review. So 1.4 talks about inverse of a function, and I always harp on this one. Inverse means reverse. If you remember, inverse means reverse, inverse means reverse, inverse means reverse, inverse means reverse. One more time.
That was easy.
It was. Inverse means reverse. What you do to find the inverse function, if f of x is, for example, y equals x plus 2, then you simply reverse x and y. Let me just try this here. So I've done this already. So you see how this x and this y are reversed. And that becomes x equals y plus 2. If you solve then for y, get y all by itself and positive, now you have the inverse graph right here. So that is the equation of the inverse graph. Couple things to note. The notation here, f to the negative 1 of x. That's the notation for inverse. And when I say inverse means reverse, this is how the book says it. If f has domain A and range B, then the inverse has domain B and range A. That means x and y reverse. That's all that means, okay? All right. Now, what about the graph of the inverse? This is interesting, okay? If we have a point that's on the original graph, let's say 2, 1, and we reverse, well, then the new point on the inverse graph is 1, 2. See that? What about if the original point was negative 3, 1 over here? Well, the inverse point would be 1, negative 3. And what I mean to show you here is that this y equals x line, okay, it's a reflection about this y equals x line. So these are reflected. See, it's like it's a mirror. Like it's a mirror. They're the exact same distance away from that line. And our little example up here, look at this. Y equals x plus 2. Well, I'm going to bring this line over here, and this is going to be y equals x plus 2. See that? And what about our inverse? Well, y equals x minus 2. And that's actually a straight line as well with, come on now, a straight line with slope 1 and y-intercept of negative 2. So you see how this pink line and the black line are actually mirror reflections, okay? If we, let's say we had a line that was something like this, well, that's no problem. The inverse would be the reflection about the y equals x line, and it looks like that. So those would be inverses, okay? So I don't know if you can see that there. Do you see that? They would meet, the point that's on y equals x would be the same point for both graphs, okay? But yeah, that's kind of what it looks like. It's a reflection about that y equals x line. Now, Desmos, oh yeah, a little reminder there. So let's go to Desmos transformations. Okay, so here I've got this graph. This is a black graph right here. It's just a random function I made. Oh, this is translations. What am I doing? Inverse. Okay, this is a different one. Here we go. Inverse. There we go. I went past that one for translations. You guys get it. So inverse. Okay, well, let's see. Here's the y equals x line. Here is an example of a parabola. Okay, and I just got it written up here. It doesn't matter what it is. But this, I've got x and y flipped. Now watch. Here is, see, that's the inverse. Now look at that orange line is a mirror, right? Okay, let's get rid of those. What about this one? Okay, here's a parabola. Oh, it dips below there. Is that a problem? Nope. Look at that. So it's a reflection about the y equals x line. No problem.
That was easy.
It was. What about this one? Okay. Oh, that's crazy. Oh, wait. Oh, I'm giving something away here. Okay, this one here. What about this? Notice that if you have it in this form, okay, notice on the left side here, see there's a restriction there because we got a root sign there. Okay. Now, x cannot be less than -4, right? So that's why over here, -4, there is nothing to the left of it. And when you do the inverse and solve for y here, you're taking the square root, which comes with it a plus or minus, right? When you take the square root of something. So the positive version will be this part, and the negative version of the inverse will be this part. So that makes the full parabola. Okay, so I guess that's just to show you the different formats. More on that a little bit later. Okay. All right, let's get out of there if I can. Hello, minimize. Okay. What about the horizontal line test? What's that? Well, if a horizontal line passes through the function and it only passes through once, that means that the inverse is a function. If a horizontal line passes through a function more than once, then the inverse is not a function. And that's kind of what I'm showing you here. See the green one? A horizontal line would pass through this green graph twice. That means that its inverse is not a function. And of course, if we sketch the complete inverse, not a function because it does not pass the vertical line test. And it kind of makes sense. Hopefully you see that if something does not pass the horizontal line test, then its inverse would not pass the vertical line test. All right, and I think this is it. That's all I have for you. Okay, so just going back to that graph, how could the domain of the graph of f of x in this case be specified? And this is terminology that you'll hear in this course. How could it be? How could we make it specific, or reduce it, or specify a specific domain in order to make the function inverse, the inverse a function? So right now the inverse is not a function, right? Well, watch this. If I restrict the domain to everything less than or equal to +2 here for the original f of x, if I restrict that domain, that means that its inverse will be this. And the inverse will be a function. So you kind of have to say, okay, let's pick a part of the domain, and so that it passes the horizontal line test, so its inverse would be a function. So this is one option. There's two options. You could say x has to be less than or equal to 2, and that would work. And then the inverse would be a function. What else you could do, let's just back up here. Oh, that's not what I wanted to do. Okay. Where am I? Oh, nope, don't want to do that. Okay, so let's say I back it up some more. Now, let's say I wanted to just have this half of the original parabola. Would that work? Yeah, sure it would. The inverse then would be this half, right? So you could also say x has to be greater than. Did I do a greater than last time? I can't remember now. X is greater than or equal to +2. And before it should have been less than. I'm not sure what I did. That just looks like I just did that twice. So, okay. So if you specify the domain, you can take a part of the original graph so that its inverse is also a function. And that's just a question you'll run into. Okay, so that's chapter 1. Okay, that's chapter 1. Everything in there that you've learned in chapter 1, you should be ready for your test now. And yeah, please feel free to look up my other videos, full lesson videos. And I have a lot of homework questions that I've recorded as well for sections like this as well. So yeah, you can look those up. Okay, hope your test goes well for you.